lessons in case you have to refer back to them. They're posted on Schoology. I don't know if you know about Schoology, but it's a platform we use here at the school. Why is that showing up? And we will use Desmos. We don't use TI. And you can always use your phone. It's open note, open book, open phone, open person test and quizzes. I've heard this class makes most students cry themselves asleep at night. Deal? Other things you should know about me: I have a bad sense of humor. I laugh when old people fall. But other than that, you'll figure out the rest. Like, okay, Stirp, you're making me feel uncomfortable now. All right, so we're cheating the system a little bit. We're showing us how to graph, or we're graphing a parabola when we just want to factor it. And all we have to do is reverse engineer it. So 6x squared plus or minus x, and then minus 2. All right, this is a good one to take a look at. Well, hello. How you be?
Terrible.
Well, you're seeing me now. Oh. I'm happy to see you. You said you're terrible. I want to make it better.
Stay.
Okay, what can I do to make it better? Stop talking. I'm just kidding. All right. Well, I am happy you're here. So we're just taking a look at this problem. So we have these two. Oh, you know, when I'm graphing this and it's not showing up on the board, it makes it kind of hard to deal with my lesson. So hopefully that'll connect. Come on, baby. Yes. All right, there we go. So we have these two different locations that crosses the x-axis. One is -5 and one is 0.667. Okay. So we were talking about how to reverse engineer a lot of these things. So we got, oops, come on, go here. We got x equals, I'm so dumb, I can't remember, -0.5, okay. -0.5, and x equals 0.6667. Okay? So we talked about yesterday that 0.5 is the same thing as 1/2. And then we have to kind of think about 0.6667 is the same thing as 2/3. Okay, I realize it's a terminated decimal they show. What they probably should have shown is they probably should have had a bar above just the 1/6. That would have been truly 2/3. But for the sake of Stirrup, we'll just keep it like that. So I'm going to just reverse these. I'm going to go x equals -1/2 and x equals 2/3. Clear the denominator, multiply both sides, not by a dotted 2. Multiply both sides by 2, so I get 2x equals -1. So 2x plus 1, that's our first. And then multiply both sides by 3. And then I get 3x minus 2. And again, this becomes the easier way of factoring because you've heard me that there's all these different tricks to factoring. But they're tricks, they're methodologies. They're not showing the true understanding of what it actually comes out to. Now, there truly are some of these that this method would not work on, because if we had an irrational situation, it means basically there was a square root that took place someplace. And we've got to be a little worried about that. Is there any of the other problems, 1 through 9, that I needed to go over? 6? We did 6 yesterday, right? Didn't I? Oh. All right. Yeah, is it 2x, 10x to the what? Third? Y to the fourth? Minus 25x squared? Y to the fifth? So this is really the only one that was on this page, I believe, that doesn't work the right way. So basically you have to look at this and you have to realize that 5 goes into 10 and 25, so that you have a 2 and a -5 that still take place. And then you have to say, okay, x to the third is xxx, x to the second is xx. So I can take a maximum of xx out, which is x squared, which leaves one of these behind. And then I have y to the fourth, which is y to the fifth, which is y. Maybe I said enough, I don't know. So I can factor a maximum of 4 of those out. So all of them factor out of the first one, and there's one left behind. And this is basically where it would have factored down to. This is as far as you could go. Okay? But again, not every trick will work. Unfortunately, Desmos only graphs in 2 dimension. It doesn't go to multi-dimensions. But that's kind of where we get goofed up. All right. Any of the others 1 through 9 that you're looking at saying it's silly how it worked that way? 7, I haven't taught that. Oh yeah, 7 I was assigned you, right? Cool. 6x to the third plus 8x squared minus 8x. I like this one. So let's graph it first, see what happens. So x to the third, see either end behavior is going to look like this or this, depending upon which way I'm standing, right? Like, what's he doing? Just go with it. All right. So I'm going to change this to y equals 6x to the third plus 8x squared minus 8x. Oops, 8x. All right. So again, it kind of has stuff that looks like that. Agree? Okay. So on the parabolas, we were worried about where it crosses the x-axis. Do you think I'd worry about where it crosses the y-axis at this point, or do you think I'm still on the x-axis? All right. So I have -2, I have 0, and I have 0.66667, which is, we just discovered, is the same thing as 2/3. And I realized that Desmos, they should have had 0.6 with a line above it, but it didn't. So I have -2, x equals 0, and x equals 0.6667. Am I still correct? Did I do it right? I did. All right. So what's the binomial for this one? Yeah, so x plus 2. What is the binomial for this one? Anyone know? Just this one. X equals 0. Is there a binomial? Or is it just an x? What do you think? Just an x. And then this is x equals 2/3. Multiply both sides by 3. Subtract 2. Now, the question is this one correct? So let me just make sure. It was number 7, right? Okay. This answer is almost right. As far as the graph went, it's showing where it's crossing. But if I were to multiply this whole thing out, I would not get 6x to the third plus 8x squared minus 8x. Okay, so anyone want to take a shot at what we are missing up there? Yeah. A 2? Yeah, 2 on the outside. So let's verify why that works. Well, these right away, I could have said, well, I could have pulled the 2 out front and it would have given me this. Oops. Could have done that. And then you could say I can still factor out the x from there. So sometimes you might have to you get the Desmos answered, but then go back and take a look and make sure that you didn't have a greatest common factor that you could have taken out of each one of them. Okay. You all feel okay with this? Do me a favor. Will you try number 13 for me? Is that 24? Oops. 24x to the fourth y. 30x. Is it x squared or x to the third? Squared and y squared? Thank you. So see if you can try that one. See if you can figure that out on your own. Every Friday is real life math applications, whether it's related to this or not. This Friday, I'm going to progress to show you how to become a millionaire, but it's actually a 4-part series.
Okay.
Okay. I'll also teach you how to buy a car, how insurances are scams, what to look out for. I go through a lot of it. It's every Friday. And it's a class that you'll probably walk out of here and never have homework in. So I opened up about 3 hours each night for you now.
Yeah.
Right?
Yeah.
But I might not teach at the level that you guys were learning at. I have a whole lot of sarcasm. I think you'll get some stuff out of this class. All right, friends. What's the biggest number that goes into 24 and goes into 30? 6. I like it. So that leaves me a 4 and a 5 behind with a plus sign there at the 5. What's the maximum number of x's I can factor out of both of those? So x squared. And that means I'm left behind with an x squared here. But this one here doesn't have an x squared, does it? Because it factored out. What's the maximum number of y's I can factor out? Yeah, just a single y. So this y here is gone. This one has a y behind it. And then you get this colorful looking problem there. Anything else on that page that's like, wait, I'm not quite sure? 14's done kind of the same way. All right, let's flip the page. All right. There's something up here, it's called synthetic division. Synthetic division is unbelievable to use when Desmos doesn't always work. Synthetic division is a way that you break down your binomial in a factored form. But the very first thing I would do with any of these problems is I would plug it into Desmos and try and determine where it crosses the x-axis. But not every time. These types of problems. Let's go to the long version in a very quick way. Descartes. We talked about Descartes. What did he make? Went the wrong way, and why? He made the XY axis. He was left-handed, so it goes counterclockwise. It's the only reason it's counterclockwise. Okay? But Descartes, or Descartes, however you want me to say it, had a way of doing these types of things to figure out where it crossed the x-axis before graphing calculators and Desmos came around. This was a long time ago. And basically what he did is he took all the factors of 15, 1, 3, 5, and 15, or all the factors of 15, over all the factors of your lead coefficient of 1, and that could find you your positive, so to the right of the y-axis, roots. And then if you plug the negative x in, that could show your negatives. But he also did something where the number of sign changes. I went from positive to negative, there's 1 sign change. Negative to positive, there's 2. Positive to negative, 3. So that means there are 3 or 1 positive to the right of the x or y-axis roots. Actually, let's take this problem and show you the really long version of this. And you don't have to take notes on this because I'm going to show you the faster route. But x to the third minus 5x squared plus 3x minus 15. Yes, this could be done real quickly with factor by grouping, but let's figure out xy axis. Agreed? Okay, so using blue, I go from positive to negative. There's a sign change. Negative, positive, sign change. Positive, negative, sign change. So you have 3 or 1 solutions over here. How many solutions should this problem have as an entirety? It's raised to the third power, so it should have 3. Solution is a number that we would plug in that would make the whole thing 0. It's not necessarily a solution where it would cross the x-axis, especially if you were dealing with the imaginary number system, which is part of the complex number system, which is the larger number system than the real number system. But mathematicians decided that. And then Descartes said, hey, if I take negative x and I plug it in to all of my x's, and I simplify my thing. So if I go negative x, negative x, negative x, I still get negative x to the third. And then this one, negative x times negative x is positive x. Positive x times negative is going to give me negative 5x squared. And then 3 times negative x is negative 3x. And then I get a minus 15. And you look here saying, do I have any sign changes here, here, or here? And there's 0 sign changes. That means I have 0 solutions that happen on this side of the y-axis. Okay? So that was Descartes started figuring out. And then he said, okay, you're going to take all of the factors of 15. All the factors of 15 are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, all over all the factors of 1, which are plus or minus 1. So if you go through the math on this, this has 8 different possible solutions to this problem of where it crosses the x-axis, as long as none of them are imaginary. Okay, so being I used Descartes' rule of signs to show we had 3 sign changes over here. Descartes' rule of signs had no sign changes over here. This automatically would have said, well, these all would have to be positive if they existed. So now I've just eliminated half my number sets to worry about. Still following me? Now we have to decide, is there 3 solutions, 3 places it crosses our x-axis on the right side of the y-axis, or is there 1? If there's 3, that means we have 3 real solutions, or 3 rational solutions. A rational solution can be written as a fraction or a whole number. Or is there 1 rational solution and then 2 other solutions that are irrational? And irrational solutions are numbers that you can't write as a fraction. It's a decimal that goes on forever. It never repeats. Okay? It's like saying the square root of 2. That decimal, if you type it in your calculator, it'll take it out 10 spots. But in theory, square root of 2 goes on and on forever. It becomes an infinite sequence or series. Okay, so now I know that 1, 3, 5, and 15 are going to work. So now I'm going to take it to the next thing. I'm going to keep the 1, 3, 5, and 15. This is what I'm worried about. And I'm going to take my original equation, which was x to the third minus 5x squared plus 3x minus 15. And we're going to use something called synthetic division to make it work. So I'm going to take 1 and I'm going to use synthetic division. Synthetic division works this way. First thing you check for. I go x to the third, x to the second, x to the first, x to the 0. Okay, there's no gaps. I take my lead coefficients. 1, negative 5, 3, negative 15. And then we go through and we do the math. Kid you not, synthetic division seems like a really made-up math. Lead coefficient comes straight down, multiply 1 times 1, which is 1. Add these together, it gives me negative 4. Negative 4 times 1 is negative 4. Add these together, I get negative 1. Negative 1 times negative 1 is negative 1, which gives me an answer of negative 16. Which means which means 1 comma negative 16 is on our graph. Okay? This right here means it's on our graph. So if you think about where 1, negative 16 exists, 1, negative 16 is like down here. Is 1, negative 16 where it crosses the x-axis? No. So you have to continue on with Descartes' rule of signs. And again, this was all how the math had to be done before we had graphing calculators. So you go through the logic saying, okay, 1 didn't work. Let's see if 3 works. And 3, we have to go with this. Deed coefficient comes straight down. 1 times 3 is 3. Negative 5 plus 3 is negative 2. Negative 2 times 3 is negative 6. 3 minus 6 is negative 3. Negative 3 times 3 is negative 9. So this gives me negative 24, which means the point 3 comma negative 24 is on our graph. Is that a solution? Well, 3 negative 24 is like down over here in the world of pretendness. Is that where it crosses the x-axis? No. Is our graph increasing or decreasing at that point? I don't know. There could be an infinite amount of possibilities we went through it, but we're not sure. So we're going to go back. Okay. Let's see if 1 doesn't work and 3 doesn't work. Well, let's see if 5 works. I got 1, 3, 5, 15. And again, using synthetic division, bring this down. 1 times 5 is 5. Add those, I get 8. 8 times 5 is 40. It gives me 45. Yes. Thank you. Oh my gosh. I can't take stirrup anywhere. You should see me at the mall. My wife didn't let me go with her anymore. I like to get in people's way.
Explain. What do you mean?
Well, you know when you're walking towards somebody and you do the little dance, the right-left dance until you both figure it out? I keep the dance going. I don't stop. So my wife says, you're embarrassing me. You don't come to the mall with me any longer because I'm a bad person. I find humor and stuff. My wife says, you're acting like a child, and I'll take it as a compliment. Thanks for noticing. All right, 1 comes straight down. 1 times 5 is 5. Add those together, that's 0. 0 times 5 is 5. Oh, jeez. I'm thinking about dancing the wrong way. 0 times 5 is 0. Add those together, that's 3. 3 times 5 is 15. Look what just happened here, my friends. That means that x minus 5 is part of that factored out. Why is that? Because the very last term became a 0. So now we have found that we have one real solution. Now, I got to bring this down. Extend my page. Show you what's going on here. All right. So do you agree that this started out as x to the third, x to the second, x to the first, x to the 0? Does that make sense? Now we have this, which is basically x squared plus 0x plus 3, which simplifies down a little further to be x squared plus 3. And if I try to solve this, I will wind up getting x squared equals negative 3. And what happened here, friends? Who took high enough math? What do I put? Plus or minus root 3? We're forgetting one thing. I. Did Stirrup just make some math up? Okay. So, this is imaginary. Actually, it's complex. Imaginary, which is part of the complex number system. Okay? Which basically means this, in most intensive purposes, won't cross x-axis. Okay? Now, I just did, that's how you used to have to do this problem in the olden days. It was fun. You want to know where it made it more fun? Okay, I had a math class. I remember the teacher gave us this. This might not be the exact problem. I'm just arbitrarily making this up. Plus 60. So this has 7 solutions to it. So you go through and say, okay, do I have any sign changes? No. Then you plug negative x in, see if you create any sign changes to get anything on the left side. The nice thing is you're going to be one real solution, I guarantee, to this problem, because this problem, when you graph it, it's going to look something like this, where someplace it's going to cross the x-axis. Now, it might cross the x-axis 7 times, but not in that. This particular type of problem raised to the 7th power, where you're taking all of the factors of 60 over all the factors of 40. Let me just show you all the factors of 60. I'm going to write plus or minus 1 time. 1, 2, 3, 4, 5, 6, 10, 12. Where am I at now? 5, 15, 20, 30, and 60 over all of the factors of 40, which are 1, 2, 4, 5, 8, 10, 20, thank you, and 40. So those are all plus or minus. So look at this. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's just using 1. Now some of them will reduce because of the 2s and the 4s, and even the 5s and the 8s and the 10s and the 20s and the 40s. Some will reduce. But all of a sudden you wind up saying, yeah, I found that 12/5 is one of the solutions, and you're synthetically dividing with that. Yeah, those were the good old days. Those were the days where I'd sit at the library, work on one problem, and the librarian would say, sir, you've been sitting here since noon. It's now 9:30. We've been closed for half an hour. Sorry. What are you working on? No, don't mess it up. It's in order. And I would figure it out. But I got a kind of a weird mind. I mean, I told you guys, I like to keep the dance going in front of people. It's just who I am. And it was fun. I enjoyed it. Don't get me wrong. But it's not for everybody. I mean, not everybody has a weird sense of humor like me. So let's go back to that original problem and take a look at how Desmos would have done this. Minus 5x squared plus 3x. Minus 15. All right, remember we said that it's crossing 1 time? Was that one of my solutions I had on my homework on that one problem? I had 6. That's 5, right? So, remember where I said you have 1 or 3 real solutions? This is my one real solution. Somewhere in this miracle down here is where those other 2 in the imaginary number system. So right now, this number system is real number to real number. Whereas reality, if I wanted to really screw things up, I keep this as real number and I change this to complex number, aka an imaginary number, so it takes place. So that's like, I'm twisting your mind around a lot with this stuff, and I know that. But we're going to play along more with this on tomorrow's Friday, isn't it? Should we do the next time we get to play with this? Monday. What do we learn tomorrow? Yeah, I can't make you a millionaire right away. But we have time. We have time. Just each of you bring me $1,000 by the end of tomorrow. And then you don't see me on Monday, but I'm just kidding. So where's Turk goes? This guy's gonna make us rich. Oh, wait a minute. Scams out of money. All right. So my friends, I think it would be fair to say that you finished this entire page. So finish just this side by Monday. So that'd be 1 through 15 all. Deal? Is that too much?
No.
Everyone losing sleep off that?
No.
I want to give you the time to kind of work through this because we're out of here. What time? 54? Okay, you got like 10 minutes to get working on this. And that's all I got.